Question number 1. A small business owner, David, is creating a simple encryption program to protect customer data. He needs to convert the ASCII Denary value of the letter N, which is 78, into binary representation for a specific part of the encryption algorithm. Give the binary number for ASCII Denary number 78. So how do we convert the Denary numbers to binary? So it's a pretty simple process. We just divide the number by 2, okay, and then if the number is even, here the remainder is 0. If the number is odd, like 9 and 19, the remainder is what? 1. So let's now add the step number 2 is to add the reminders, okay. So if the number is even, the remainder is 0, okay, so 0, and then 9 is odd, that's why the remainder is 1. 19 is odd, remainder is 1. 39 is odd, remainder is 1. 78 is even number, that's why the remainder is 0. And the last step is we need to write those numbers in the order so we can get the binary value. So how we write from top to bottom. So we start from this number 1 0 0 0 1 1 0. So this is our binary number for the 78 Denary number. Okay, and since we need to write our answer in 8 bits, that's why we add one extra 0 here, and rest of this number is equal to this number. Let's move to the question number 2. Question number 2, convert A to F to binary. So A to F is the hexadecimal number. We need to convert this number to binary. So how do we convert the hexadecimal numbers into binary? First of all, you need to know one rule that, not rule, is information like one hexadecimal number is equal to 4 bits. So 4 binary numbers can represent one hexadecimal number. Okay, so let's write the number A, 2, and F in this form, and underneath we can write the powers of 2 starting from 1 2 4 8. So see, we have 4 powers, 1 2 3 and 4. Next, you can look at this table. So here this table represents the Denary numbers on the top and the hexadecimal numbers on the bottom. Okay, so Denary numbers and the binary numbers, Denary and hexadecimal numbers same from 0 to 9, but hexadecimal number does not have the number 10. It represents the number 10 as A, 11 as B, 12 as C, 13 as D, 14 as E, and 15 as F. Okay, so now we know. So now let's first convert the first number. First number is what? 10. So what is the binary of 10? If you divide the number, divide by 2 and add the carry, so we know we get the number 1 0 1 0. So that is the binary of the number A, or the letter A. Then 2 is same 2, so the binary of 2 is 0 0 1 0. F is what? 15. So what is the binary of 15? 15 is what? 1 1 1 and 1. So that's our answer. So our answer is what? Our answer is 10 00 10, and let's go to the question number 3. The binary number stored for an address is this long number, binary number. Okay, convert the binary number to hexadecimal. So now we need to convert this long binary number into hexadecimal. Okay, so what we know that one hexadecimal number can be represented by 4 binary numbers, okay, or 4 bits. So step number 1 is to split the number into group of 4 bits. So we split this number into group of 4 bits. So first, next 4 bit, and the next 4 bit. Next we just convert each group individually to the Denary. So what is this number? So it's 0 1. So it's 1. Next one is what? 1 8 plus 1 is 9, and the last number is 1 0 1 1, which is 11. So 1 in the Denary is what? 1. 9 is also 9. 11 here, 11 is what? B. So the answer is 19B. Question number 4. The 2 binary integers and this number are added together. Add the binary integers using the binary addition and show your answer in binary. So now we need to add 2 binary numbers. So here are the rules that you need to keep in mind when adding the 2 binary numbers. So the rule number 1 says 0 plus 0 is sum is 0 and carry is 1. Rule number 2 says 0 plus 1, sum is 1 and carry is 0. Rule number 3 says 1 plus 1 is sum is 0 and carry is 1. And rule number 4 says 1 plus 1 plus 1 is sum is 1 and the carry is 1. So now let's keep these rules in mind and try to add those numbers together. So let's see the first number. So it's 0 plus 0. So 0 plus 0, we know sum is 0 and carry is 0. So the sum is 0 here. We don't need to add the carry. Next, 0 plus 1 is what? 1. 0 plus 1 again is 1. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 1. So 1 plus 1 is what? Sum is 0 and carry is 1. So sum is 0, carry is 1. Okay. So now we use the same thing. 1 plus 0. Oh, sorry, 1 plus 1 again, right? Because we ignored the 0. 1 plus 1 is what? 0 is sum and 1 is carry. So now 1 plus 0 is what? 1. So here is our answer is 1 0 0 1 0 1 1 0. Let's go to the next question. Two binary numbers are added by a computer and an overflow error occurs. Explain why the overflow error occurred. So let's talk about the overflow error. So why the overflow error occurs? So an overflow error occurs when the result of the binary addition is too large to be stored in the allocated number of bits, causing the loss of most significant bits. That's the simple answer that you can write. Okay, let's move to the next question. Next question says this number can be stored as 2's complement integer. Convert the 2's complement integer this to Denary. Show all you are working. So now we need to convert this 2's complement binary number into Denary number. Okay, so what is the 2's complement number? So 2's complement is a method that we use to represent the signed number. So what are the signed numbers? So numbers with the, let's say, minus something or plus something. Okay, so in those numbers, the last or the most significant bit, in this case this one, is a sign bit. It's called the sign bit. Okay, so if the sign bit is 0, it means the number is positive. If the sign bit is 1, it means that the number is negative. So you can see here that the sign bit is 1, which means this number is negative number. Okay, so how do we convert the 2's complement integer to Denary? So same thing, we just need to know that the most significant bit here is minus 128. Why minus 128? Because it's the 8-bit number. So the last bit is equal to minus 128. So let's see. We first need to add the powers of 2. 1, 2, 4, 8, 16, 32, 64, and minus 128. Then we just need to put this number underneath those powers of 2. Okay, so here we can see same number, 1 0, okay, 1, and then 000 and 111. Then we just need to simply add the numbers where we see the 1 underneath. For example, 32 plus 2 plus 1, because they have 1 underneath, and we ignore the numbers with the 0 underneath. So let's add first the positive number. So 32 plus 2 plus 1 is what? 35. 35 plus minus 128. So minus 128 plus 35 will get the answer minus 93. So this number, this long number, 8-bit number, is equal to minus 93. Let's go to the next question. Next question says the Denary integer minus 32 is stored as 2's complement integer. Calculate the 2's complement integer that would be stored. So now we need to convert minus 32 into the 2's complement. And we need to give the binary number of minus 32. Okay, so it's very simple to convert a negative number to binary using 2's complement. So step number 1 is you just ignore the sign. So we ignore the sign and we just convert 32 to binary. So what is the binary of 32? Here you can see the binary of 32. And also remember, we need to have one extra bit for the sign bit. If you just convert the number to 32 to binary and do not leave any, you don't have any sign bit, then your answer will be incorrect. So make sure you have 1 or 2 extra bits for the sign bits. Okay. Step number 2 is to flip the bits. So now we flip the bits. 0 will become 1 and 1 will become 0. So as you can see, this 0 became 1, 0 to 1, 1 to 0. We just flip all the bits. Next is we need to add plus 1 to this number, to those flip bits. Okay, we add plus 1. So now we know the rules. Okay, 1 plus 1 is 0, 1 carry, 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 1 plus 1 is 0, 1 carry. So now here we have a 0 plus 1 is 1, and then just we can write this one as it is and this one as it is. So this is our binary. This is the binary number for minus 32. Let's go to the question number 8. So question number 8 is what is the binary number. This number is stored in random access memory or the RAM. Give 8-bit binary number that will be stored after the shift has taken place. A logical left shift of 3 places is performed on the binary number. So now we need to perform a shift on this number and then need to store, give the what happened after the shift. We need to give the numbers. So remember, we have to do what? We have to do a logical left shift and we have to do it 3 places. Okay, so it's pretty easy. So step number 1 is you just delete the 3 bits from the left side. Okay, because it's saying the left shift, right? So in the left shift we just remove the 3 or whatever number they give it to us, like say 4 bits or 5 bits. You just remove that number of bits from the left side. Okay, then step number 2, you add 3 zeros on the opposite side. In this case, add 3 zeros on the right side, and that's your answer. So here you can see this is our answer. That's a very simple method to convert to perform a logical left or the right shift. Okay, next, a value is stored as binary number in a register. So this is the value. A logical right shift of 3 places is performed on the binary numbers. Complete the binary register to show its content after the logical right shift. How can we do that? So if this is the number, okay, so this time we have to perform what? We have to perform the right shift, and how many places? 3 places. So same thing, this time we just remove the 3 bits from the right side, and then we add 3 zeros on the left side. Okay, so our answer is this one. Let's go to the question number 10. Give 2 reasons why a programmer may use hexadecimal to represent binary numbers. So now we need to give the 2 reasons to why the programmers use the hexadecimal. Okay, so the first reason is hexadecimal is more compact or shorter representation. For example, we know that one hexadecimal number is equal to 4 bits. So instead of writing 4 bits, we can write one hexadecimal number. So it's shorter. Second one is easy conversion to and from the binary. So it's very easy to convert a binary number to hexadecimal and a hexadecimal number to binary. So that is why the programmers use the hexadecimal instead of binary. Question number 11. Identify 2 ways that hexadecimal is used in computer science. So there are so many ways where we use hexadecimal in computer science. For example, we use the hexadecimal in HTML color codes. Okay, in URLs or uniform resource locators, memory dumps, IP addresses like IPv6 uses hexadecimal, MAC addresses. Okay, assembly language uses the hexadecimal. Error codes, we use the hexadecimal in error codes to show the different error messages, and ASCII and Unicode also uses the hexadecimal. So these are the some uses for hexadecimal in computer science. Question number 12. The binary number is measured as byte because it has 4 bits. I guess we know the 8 bits is equal to 1 byte, right? State how many bytes there are in a KB byte. So here you can see. So we know 1 bit is equal to either 0 or 1. Okay. 4 bits is equal to 1 nibble. 8 bits equal to 1 byte. 1024 bytes equal to 1 KB byte. 1024 KB byte is equal to 1 megabyte. 1024 megabyte is equal to 1 gigabyte, and 1024 gigabyte is equal to 1 terabyte. So what is the answer? The answer is 1024. Okay. Let's see the next question. Question number 13. A computer comes with primary and secondary storage. Data storage is measured using the binary denominations. Complete each conversion. So the first we have 8 bytes equal to dash nibbles. 512 KB byte is equal to dash megabyte. 4 GB byte is equal to dash megabytes. 1 exabyte is equal to 4 petabyte. So what is the answer? 8 bytes is equal to what? 16 nibbles. Because 1 nibble is equal to what? 4 bits. 512 KB byte is equal to 0.5 megabyte. 4 GB byte is equal to how many bytes? 4096 megabyte. And 1 exabyte is equal to 1024 petabyte. Let's move to the question. Question number 14. A museum archivists need to store a large collection of historical document as text files. To save storage space, they decide to use the lossless compression. State what effect this has on the file size of the document. So let's see. So number 1, compression. We know there are 2 types of compression. One is called the lossy compression. The other one is called the lossless compression. If you use the lossy compression, it reduces the file size, but it permanently removes data from the file. Okay, so it reduces the file size by permanently removing the data. But the lossless compression, it also reduces the file size, but it does not remove any data from the file. Okay, so what is the purpose of those? So the first purpose is to reduce the file size. Second, make the file size smaller. decrease the amount of storage needed. So these are the few reasons that you can write for this answer. Question number 15, a software company need to archive old project documentation. They want to use lossless compression to reduce the file size without losing any data. Describe how lossless compression compresses a text file. So now we need to tell how the lossless compression can compress a text file. Okay, so lossless compression reduces the file size without losing any data. Okay, we know that. Then it identifies pattern or a repeated sequence of data. It stores these pattern or sequence using the shorter representation, for example, indexes. When the file is decompressed, the original data is perfectly reconstructed. And an example of the lossless compression is the run length encoding, RLE, which replaces the repeated sequence of the same characters with a count and the character. Let's go to the question number 16. A text file can be compressed using lossless compression. Give 2 reasons why the text file may have been compressed. Same thing, to reduce the storage space required to store the files. Okay, to speed up the transmission. For example, if the file size is smaller, it can be quickly sent, right? So the download time is much lower. Then number 3, to reduce the bandwidth usage. So if the file size is small, it will use the less band when you're transmitting over the internet. And to allow more files to be stored. So if the size of the file is smaller, which means you can store more files on the same disk. Question number 17. Georgia compresses a photograph to store them on a USB flash memory drive. It is important that the compression does not affect the quality of the photographs in any way. State which type of compression is the most suitable. Justify your answer. This time, Georgia want to compress the photographs, but what is the requirement? She doesn't want to lose the quality of the photograph, right? So it means she doesn't want to use the lossy compression. So she want to use the most suitable type of compression is lossless compression because she doesn't want to lose the quality. Okay, and then lossless compression does not lose any data during the compression process. The original image can be perfectly reconstructed when the file is uncompressed. That's the answer. Question number 18. Tina uses a microphone to record a welcome message for her website. She wants to compress the recording to make sure that the file is as small as possible for the website. Identify which type of compression she should use and describe how this would compress the file for the website. So type of compression she should use is the lossy compression. Okay, lossy compression reduces the file size by permanently removing some of the data, and it identifies and discards the less important parts of the audio files, such as the frequencies that are less audible to the human ears. This results in smaller file size, but some audio quality is lost. This is acceptable for the welcome message on the website, where the file size is more important than the perfect audio. Question number 19. Tina uses a microphone to record a welcome message for her website. Gave 2 benefits of compressing the files for the website. So the first benefit of the compressing the files is it reduces the storage space required on the web server. Okay, next one is decrease the download time for the users visiting the website. Next one is reduces the bandwidth usage because it will take less time to upload or download, and allow more files to be stored on the server because the file size is smaller. Okay, and that's all. Question number 20. So question number 20. Sammy creates video for finance company's website that give customers advice about their finances. He uses lossy compression to reduce the file size of the video for the website. Gave 3 ways that lossy compression can reduce the file size of a video. So now we need to give 3 ways how the lossy compression can reduce the file size. So the first is reducing the color depth. Second one is by reducing the frame rate, reducing the resolution of the video, and removing the non-essential data from the video, and identifying and removing the redundant data. So these are the 3 different ways that it can reduce the file size. Question number 21. Audrey wants to send a sound file to a friend as an email attachment. The original sound file is too large to send as an attachment. State how Audrey can reduce the file size of the sound file. So she can use the lossy compression to reduce the sound, image, and video file size. So usually use the lossy compression to reduce the sound, image, and video file size. Okay. Question number 22. A musician has recorded a song and wants to email it to a friend. However, the uncompressed audio file is too large to send easily. Explain how lossy compression reduces the sound file size, making it easier to email. So first one is lossy compression. Reduces the file size by permanently removing some of the data from the file, removing sound that are outside the human hearing range. Okay, so some frequencies the human cannot hear, so we can also remove those one from the sound and to reduce its file size. Reducing the sampling rate, so it can also reduce the sampling rate, and reducing the bit depth resolution to reduce the file size. And the last option is this makes the file size smaller but reduces the quality of the sound, because we are removing so many things from the file. That's why it will reduce the quality of the sound. Okay. Question number 23. Explain the difference between a lossy and lossless compression. So here you can see the two tables and you can see the difference between the lossy and lossless compression. So some data is lost during the compression and reduces the file size more than lossless compression and cannot be restored to the original quality. These are the qualities of the lossy compression. Lossless compression, no data is lost during the compression, can be restored to the original quality and large file size compared to lossy compression for the same data. Okay, let's see the question number 24. Wildlife photographers store their digital images on a computer. Complete the table by defining each term about the images. Okay, so the first term is what the smallest component of the image is called the pixel. Okay, the number of pixel wide by the number of pixel high, that's called the resolution. Okay, so these are the two terms and their definitions. Question number 25. Identify 3 different file formats that can be used to store digital photographs. Okay, so what are these? JPEG, PNG, and GIF. Next question, question number 26. Identify 3 different file formats that can be used to store a digital sound recording. So it could be MP3, WAV, and AAC. Okay, these are the different file formats to store the audio. Okay, next question. In question 27, Jessica wants to store a large number of small thumbnail images on a USB flash memory drive. Each thumbnail image is 16-bit color and 100 pixel wide and 100 pixel high. She has 5 MB of storage space available on USB flash memory drive. Calculate how many images she can store in the 5 MB of storage space. So how do we calculate that one? So first of all, you need to calculate the size in the bit per image. So we just multiply the numbers. Let's say 100, 160. Okay, so you got this much bits. Okay, next we need to convert those bits to bytes. So we just divide this number by 8, and so now we got the answer in bytes. Okay, we know the total storage is 5 MB. 5 MB is equal to how many bytes? We just calculate the number of bytes in 5 MB. So this number of bytes are in the 5 MB, and then we just divide this number by this value, okay, in bytes, and then we know that we should store 26 images in that USB. Okay, question number 28. A student has a portable tablet computer. Identify 2 input devices that could be built into the portable tablet computer. So now we're talking about the tablet computer, and they want us to tell the 2 input devices that could be built in, okay, built into that. So what could be those? For example, we can say touch screen, okay, we can have microphone, a button, a camera, a device. So these devices can be built into that tablet computer. Question number 29. Julia input personal data into her computer, and she stores 3 copies of the data using a hard disk drive HDD, a solid state drive SSD, a USB flash memory drive. Identify 3 devices Julia can use to input personal data into her computer. So keyboard, a mouse, a scanner, a microphone, a webcam. So these are the different input devices that you can use to input data. Question number 29. Let me see, just give me a minute. Question number 29, question number 30. A bus station has a ticket machine. A customer can use the ticket machine to select and pay for their tickets. One input device built into the ticket machine is a touch screen. Identify two other input devices that could be built into the ticket machine. Okay, so for example, you can say keyboard, keypad, trackpad, trackball, microphone, sensor, button, barcode or QR code scanner or reader, and the last could be the webcam or the digital cam. So you can just write any two devices from the list. Okay, let's move to the question number 31. Question number 31, the ticket machine has a help icon that a user can touch to connect the customer support. The ticket machine has an output device that allows the user to hear the customer support person. Identify an output device that would be used for this purpose. So which device will give us output as audio? So it could be a speaker or the headphone. Okay, question number 32. A museum is creating an interactive information point for the visitor. Identify one output device that could be built into the information point. Give an example of how that device would be used in the context. Okay, so let's say you can say the display screen or the monitor or the touch screen to see a shop location. Okay, a speaker or headphone, for example, to hear where a shop is located. A printer to get a hard copy of shop information. LED light, as a light, for example, to indicate where a shop is on the map. Question number 33. So question number 33 is a library has a self-checkout system that allow customers to register books that they want. The microprocessor also uses output to control the system. Gave 3 examples of output that the microprocessor is likely to use. Okay, so for example, sound to a speaker, a text to a screen, data to a printer, image to a projector. So this is the answer. You can choose one. Okay, next question. Question number 34. A shopping mall has an information point. Visitor can use it to find out which shops are in the mall and where they are located. Identify one input device that could be built into information point. Give an example of how that device would be used. Okay, so let's see, for example, keyboard to type in the shop name, a mouse to click on a shop, a microphone to speak the shop name as a voice command, touch screen to select a shop, barcode scanner to scan barcode for vouchers, a sensor to detect when a person walk past, and webcam, for example, to make a video call for assistant. Okay, next question number 35. Which statement is correct about RAM or random access memory? First one, A, it is not directly accessible by the CPU. Option B, it is not storage. Option C, it stores data that is currently in use. Option D, it store bootloader. So I want you to comment your answer. Let me see if you know the correct answer or not. Well done, some of you gave me the correct answer. So yeah, it's correct. So the correct answer is C. It stores data that is currently in use. Well done. Well done. Question number 36. 5 components are shown. Show whether each component is an example of input, output, or storage. So first one is actuator, then you have register, then sensor, and then we have mouse, and the digital versatile disk or DVD. So the first component, let's talk about the first one, is actuator. Actuator is what? Is input device or output device or a storage device. So actuator is an output device. Okay. Next one is register. Register is what? Is a storage device, right? It's inside the CPU. It stores the address or the data or the instructions. Next one is sensor. Sensor is an input device. It captures the data from its immediate surroundings, right? Next one is mouse. I think all of you know it's an input device. And the DVD, maybe some of you know about the DVD. DVD is a storage device. Okay, so question number 37 is what? ROM is a type of primary storage. State the characteristic of ROM that makes it a type of primary storage. So what is the definition of primary storage? Primary storage is a type of storage that is directly accessible to the CPU. So CPU can directly read the data from that primary storage. Okay. So the answer is ROM is primary storage because it's directly accessible by the CPU. Question number 38. A photographer decides to purchase a solid-state storage device to back up their images. Complete the description of solid-state storage. So what is solid-state storage? So as you can see, I fill in the blanks 1, 2, and 3. So first one is what? Is solid-state storage is dash. This means that the data is not lost when the power is turned off. So we have two types of storage. One is called the volatile storage and the other one is called the non-volatile storage. Volatile storage stores the data only when it has power, for example, the RAM. On the other side, the non-volatile storage can store data if there is no power. Okay, so it's solid state is a storage is a non-volatile storage. Number two, solid state storage is made of dash that are laid out in a dash. It's made about what? Transistors and laid out in a grid. Number three, gates are used to control what? Flow of electrons. Okay, through the transistors, this changes the data in that transistor from 1 to 0 and from 0 to 1. Question number 39. 5 statements are shown about the random access memory or the RAM, an internal SSD or solid state drive, and a USB flash memory drive. Tick to show which statement applied to each component. Some statement may apply to more than one component. The first statement is it's a type of primary storage. So which one is a type of primary storage? RAM, internal SSD, or USB flash. So RAM is the type of primary storage. Next statement, it's volatile. So what is mean by the volatile? So it can only retain the data when there is a power. So it's RAM. Internal SSD, HDD, USB flash memory drives, they are all non-volatile storage. It uses the NAND and NOR technology. So internal SSD and the USB flash memory drives, they uses NAND and NOR technology. Next statement is it does not have any moving parts. So which one does not have any moving parts? So RAM does not have any moving parts. Okay, SSD does not have any moving parts, and USB flash memory drive also does not have any moving parts. Last statement is it is not directly connected to the CPU. So which one is not directly connected to the CPU? It's the SSD and the USB flash memory drive. These two are not directly connected to the CPU. But RAM is directly connected to the CPU because it's a type of primary storage, and CPU can directly access the data from the RAM. Question number 40. A photographer needs to store a large number of high-resolution images. Give 2 examples of suitable secondary storage devices that could use. Okay, so what are the 2 suitable devices to store the images? So for example, we can say hard disk drive. Okay, he can use the SSD, he can use the USB flash memory, he can use DVD, CD, or Blu-ray disc to store the data, because these are the devices we can use to permanently store the data. Question number 41. A graphic designer is working on a large image file using photo editing software. Explain why their computer needs RAM to effectively handle this task. So what is the reason for using the RAM? So to store data temporarily, because whenever you open some program on the computer, that goes to the RAM. So if he has more RAM, then he can open multiple photos. Okay, and photo editing software, they are also kind of a heavy software, right? So in order to make them work properly, you have to have a large amount of RAM to store data that is currently in use. For example, the photo editing software, to store software currently in use, the data can be accessed faster than the secondary storage, and to speed up the fetch stage, for example, fetch, decode, and execute cycle. Question number 42. The computer in the finance company uses both primary and secondary storage. Give 1 example of primary storage. So what is the example of primary storage? So we can say it's RAM, random access memory, is 1 example of primary storage. ROM, read-only memory, is also an example of primary storage. And the cache memory, is also an example of primary storage. Question number 43. Random access memory, or RAM, is an example of primary storage. gave 3 examples of data that is commonly stored in the RAM. So this question is very important, and I have a quick hack for you to answer this question about the RAM. So what data is stored in the RAM? So you can just remember 2 words: currently running data, currently running instructions, currently running parts of operating system, currently running utility software. Okay, so just use the word currently and then just let's say data, instruction, part of operating system, softwares, application software, or utility software. Let's move to the next question. Question number 44. A user has both system software and application software installed on their computer. State which component in the computer would store both types of software when the power is turned off. So now we are again back to volatile and non-volatile storage concept. So what is meant by the volatile storage and what is meant by the non-volatile storage? So volatile storage is a type of storage that store data when there is power. Okay, so when there is no power, it loses all the data. On the other hand, non-volatile storage can store data even if there is no power. Okay, so for example, hard disk drive is a type of non-volatile storage. SSD is a type of non-volatile storage. Okay, so any other non-volatile memory, for example, CD, DVD, etc., and mostly the secondary storage devices, they are mostly non-volatile. Okay, question number 45. The self-checkout system uses 2 types of primary storage. Gave 2 types of secondary storage that would be used in the system. So what are the 2 types of secondary storage devices? Primary storage devices are directly accessible to the CPU. Examples: RAM and ROM. So now can you give me the 2 type of secondary storage? So we can categorize the secondary storage devices into magnetic, solid state, and you could say the, how to say this one, like CD, DVD, and the DVD and the Blu-ray disc. Okay, so these are the 3 types of devices that we can say. So the answer is hard disk drive, solid state or SSD, and the Blu-ray disc. Okay, and you can say, yeah, that's it. Okay, next question. A small business owner, Sarah, needs to store customers' data, sales records, and accounting information for long-term access and the backup. Describe the purpose of secondary storage in Sarah's business. So what is the purpose of the secondary storage? Is for permanent storage of the files, okay, and to store data that is not currently required by the CPU, and to store the data to transfer it to another computer. Okay, question number 47. A student has a computer that has a CPU. Describe the role of the CPU in the computer. So CPU is, you can think of CPU as a brain of the computer. Okay, so the purpose of the CPU or the role of the CPU is to do what? Is to process instruction or data, or you can say that it to run fetch, decode, execute cycles. Okay, so you can just write any of one line from those 2. Question number 48. The CPU contained register. State the purpose of a register. So what is the purpose of a register? Is to temporarily store data, instruction, or address, or to allow the immediate access to data during the fetch, decode, and execute cycle. Question number 49. Give 3 registers that are built into the CPU. Okay, so for example, MAR or memory address register, MDR memory data register, we have ACC accumulator register, we have PC program counter register, and we have CIR or the current instruction register. So these are the registers that are built into the CPU. Question number 50. Complete the following statement about the fetch, decode, execute cycle. Okay, yeah, here are the question is very important. If you know the answer of this question, you can easily answer any question about the fetch, decode, execute cycle in the exam. Okay, and so there is usually a question about fetch, decode, execute cycle in the exam, so I think you should memorize or understand how the data is fetched and decoded and executed by the CPU. Okay, an instruction is dashed from the RAM into the CPU. So the instruction is what? Instruction is fetched, right? Fetched from the RAM into the CPU, where it is temporarily stored in dash in where stored is stored in MDR or memory data register. The instruction is sent along dash to the CU along the data bus to the CU to be what? To be decoded, The dash will then perform the ALU, or arithmetic logic unit will then perform any calculations and the logical operation that are required to do what? To execute the instruction. So let's have a short break, and then we can continue with the past paper questions. So if you have any question, you can send me a message as in the chat, so maybe I can answer your questions. If you don't have any question, then we can continue with our. So if you don't have any question, then maybe we can continue, right? It's almost 1 hour of the stream. Okay, so on the YouTube we have 2 viewers. On the WeChat, let me see how many viewers we have. Good. Yeah, okay. Yeah, let's go to the question number. Let's start the question number 51. A supermarket uses a self-checkout system controlled by a microprocessor. This system scans items and process payments. Describe the purpose of microprocessor in the self-checkout system. Okay. So what is this one? So CPU act as a central processing unit for the computer. Okay, microprocessor. Control the operation of the self-checkout system, okay, and process data and instruction, microprocessor, because it's the same as the CPU, and perform calculation and logical comparisons, and fetch, decode, execute, fetch, decode, and execute the instructions. And the last point is manages the flow of data within the system. Question number 52. A computer technician is explaining the specification of a new computer to a customer. The computer has a single core 3.5 gigahertz processor and 8 KB cache. State what is meant by 3.5 gigahertz of the processor. So if you can, any of you can answer this question, what is mean by 3.5 gigahertz processor? It means that this CPU can perform 3.5 billion instruction per second. So it can run 3.5 billion fetch execute cycles each second, okay, or it can execute 3.5 billion instruction each second. Okay, next question number 53. A computer is performing a complex calculation involving both addition and logical comparison. Describe the purpose of the arithmetic logic unit within the CPU during this process. So what is the purpose of arithmetic logic unit? So arithmetic logic unit is a component within the CPU that can do what? That perform the calculations like addition, binary, shift, etc. To perform the logical operations like to compare two numbers, for example, compare A is greater than B, something like that, or to store the interim result of calculations, and then to store, read, write data from the accumulator. Okay, I've got a message that you can't hear properly. I don't know why you can't hear properly. Maybe it's I think WeChat, my students can hear me, and TikTok can hear me. Okay, I don't know. So, okay. So interim values, when you add two numbers, then you have the carry, and those values we call them the interim values. I don't know, dear. I think it's the problem on your side. It's not my side problem. Maybe you can refresh the page and see. Oh yes, let's continue. Question number 54. The student wants to replace the CPU to increase the performance of the computer. Explain why a different CPU can increase the performance. So number one, it could have more cores, increasing the number of fetch, decode, execute cycle it can perform at the same time. It could have a higher clock speed, increasing the number of fetch, decode, execute cycle per second it can perform. And it could have a great cache size, meaning more frequently used data can be accessed faster. Question number 55. Phil has a computer that is designed using the von Neumann model. The computer has a CPU. One type of component within the CPU is an address bus. Identify two other types of bus and state what each is responsible for transmitting in the CPU. So, can you comment the names of the buses in the comment? And give me a very short break. Let me close the door. So here's the answer. Oh, okay, well done. Some of you respond is correct. So data bus responsible for transmitting data or instructions. Then you have control bus is responsible for transmitting the control signals. Question number 56. A computer is executing a program. Identify one bus that can be found in the CPU and explain its purpose in the fetch, decode, execute cycle. So address bus transmits address between components in the CPU. Data bus transmits data between the components in the CPU. Control bus transmits control signal from control unit to the component in the CPU. Okay, very good, Abdullah, very good. I can see your message. Okay, well done. Question number 57. A computer is running on a user's computer. The CPU processes instruction in a cycle that has 3 stages, one of which is execute stage. Identify one other stage of the cycle that is performed by the CPU. I think most of you know this one. It's a fetch, decode, and execute cycle. Okay, let's move to question number 58. A programmer is writing assembly code for a simple calculator program. The program needs to store intermediate results of calculation, identify the component within the CPU that the accumulator is built into, and describe the purpose of the accumulator in the system program. So accumulator register is used to store the result of interim calculations. It's a part of ALU. It's a part of arithmetic and logic unit. Question number 59. A library has a self-checkout system that allows customers to register books that they want to borrow. The self-checkout system has a CPU, central processing unit. The CPU has 2 cores. The purpose of the core in the CPU. So what is the purpose of a core in a CPU? To perform a fetch, decode, execute cycle, or to execute an instruction. So you can think of a core as a worker. Okay, so one worker can do one thing, one job at a time, right? If you have 2 workers, so they can do 2 jobs at the same time. Okay, if you have 4 jobs can be done at the same time. Question number 60. A graphic designer, Sarah, is working on a project that involves frequently accessing and manipulating large image files. The computer she is using has its cache memory upgraded from 32 KB to 64 KB. Okay, explain how this increase in the cache memory is likely to affect the performance of her computer. So what is the use of the cache memory? Cache memory is used inside the CPU to store most frequently used instructions. Okay, so here you can see more cache improves the performance because more cache means the processor can access more frequent used data or instruction faster instead of having to access the data from the RAM. Okay. Question number 61. A supermarket is upgrading its self-checkout system. The single core CPU is replaced with the CPU that has 4 cores. Explain the effect this has on the performance of the self-checkout system. So same question again. So it may increase the performance because more instruction can be processed simultaneously at the same time. Question number 62. The CPU contains register and buses. Describe the role of register in the CPU. This question is very easy. I think most of you know what is the role of the register in the CPU. So register is a type of storage, right? So it's used to store what? It's used to store the data or address or instruction. So it's used to store data, instruction, or address temporarily. Okay, it's a type of storage. Question number 63. Data packets are transmitted across a network from one computer to another computer. Describe the structure of a data packet. Who can tell me the structure of a data packet? Quick. I just gave you maybe 5 seconds. Yes, correct answer. Yes, good. Let me see on YouTube. I think nobody is here. No problem. Let me give you the answer. So structure of a packet. So a packet has a header, a payload, and the trailer. So these are the 3 components of a data packet. Okay. Okay, very good. Very good, Abdullah. I think my stream is slow on YouTube, and well done. Okay, question number 64. The file server is moved to another building that is 1 kilometer away. Explain why the parallel simplex data transmission method that Umar uses is no longer suitable. So talking about the parallel data transmission, right? Parallel simplex, sorry. So the parallel is not suitable for long distance. Parallel cables are not manufactured above approximately 5 meters. Okay, so parallel data transmission can only be used if the length or the distance is 5 meters. Okay, and second reason, the data could be skewed if you use it for a long distance. Question number 65. A customer, Sarah, is borrowing an online store to purchase a book. Her computer A sends a request for the website homepage to the to the store server. The request is sent using the packet switching. The structure of the data packet includes a packet header, identify the two items of the data that would be contained in the packet header. So what data we have inside the packet header? So we have sender IP address, okay, the receiver IP address, packet number, and last one is error detection methods. Information is also in the packet header. So just remember sender and receiver. That's it. You're good to go. Question number 66. A wildlife photographer is using a remote camera to capture images in a national park. The camera transmits the captured photographs back to the photographer's base camp. Gave two benefit of transmitting the photographs using the serial data transmission. So what is serial data transmission? It's a way of transmitting data where we use one wire or one channel to transmit data from one device to the other device. So data won't be skewed. Okay, this is the first one. Second one, less chances of errors. Okay. Third one, transmission speed is adequate. So these are the three reasons or benefits of using the serial data transmission. Okay. Question number 67, checksum and auto repeat request or ARQ are both used when transmitting the data from a computer to the file server. Explain why checksum and ARQ are both used. So this question is a little bit tricky, and I saw this question in a few of the past papers. So make sure you understand this question. It's a kind of important question. So first, why using the checksum uses the calculated value to detect the errors during the transmission, while the ARQ checks if the data is received. It uses acknowledgement and timeout request data be sent again if checksum detects error. Yes, you can also write the benefit of the serial. Yes, it's cheaper because we're using the one wire. Okay, make sure you just fill the paper. Question number 68. A computer sends data across the network. One element of each data is packet header. Identify two other elements of the packet. So now we know is that one is payload, the other one is the trailer. So header, payload, trailer. Just memorize those names, okay? Question number 69. A computer A needs to be directly connected to a router that is located in a different room. Identify whether serial data transmission or the parallel data transmission is more suitable for this connection. Explain the reason for your answer for your choice. So this question is again tricky. Okay, so you can use both, but you have to give the reason why. So let's say if you choose the serial, so you can say data arrives in the ordered sense, less likely experience interference and can transmit over a long distance. If you choose the parallel, so you can say faster transmission speed than the serial, data may skew during the transmission and very long connection is not needed because it's the next room, right? So you can just write this answer. Question number 70. A small weather station in a remote location needs to transmit sensor data, temperature, humidity, and wind speed back to the central research lab. The station has limited power and a single communication channel. Okay, gave two benefits of a company using the serial half duplex data transmission for this purpose. So what is the benefit? Number one, bits will not be skewed because if we use the parallel, bits are skewed, right? They don't come on the time. Some bits come early, some bits come late. So that's called the data skewed. Next one, less chances of errors. Okay, less interference. Data can be sent over a long distance. Okay, using the serial. It is possible to download and upload data to the web server and high bandwidth than the full duplex. So these are the few reasons that you can write. So see, this question is 2-mark question, so you can just write any of 2 points. Question number 71. The data transmission will use parity check. The byte need to be sent using an even parity byte check. Okay, complete the parity bit for each byte. So now I give you few seconds and you tell me what is the parity bit for byte A and byte B. Yes, very good, very good, very good, very good. Most of you know this topic very well, right? So byte A is what? 0. Why it's 0? Because 1, we are using the even parity, right? So let's count. 1, 2, 3, 4. So we already have the even number of ones, that's why we use the 0. Byte B, all zeros. So we're using the even, so that's why this will be also 0. Very good. Question number 72. So the table contains statement about the error detection methods. Complete the table by giving the correct error detection method for each statement. Okay. The first one is an odd or even process can be used. Yes, that's the parity check. Next one, a value is calculated from the data using an algorithm. This happened before and after the data is transmitted. Okay, so that is checksum. A copy of data is sent back to the sender by the receiver. That's the echo check or echo check. Okay, acknowledgement and timeout are used. So that's ARQ. Okay, or automatic repeat request. And the last one, the value is appended to the data that has been calculated using the data. This value is checked out on the data entry. So data entry. So this is what this is check digit. Okay. Remember the difference between the checksum and the check digit. Checksum is used when you are transmitting data. Okay. While the check digit is used when you are entering the data. Remember this difference between checksum and check digit. Question number 73. Sensors can be used in automated system. Give two benefits of using sensors in this type of systems. So now let's talk about the sensors. Okay. So about the benefits of using the sensors. So first benefit, data can be collected without human intervention. So they can work automatically. Get this data fastest than human, okay, sensor. It will be accurate in taking readings. It can take reading 24/7. It can take reading in dangerous environments. And these are some reason, the benefits of using the sensors. Okay. Okay, identify and describe. One other method of error reduction used during the transmission. So for example, we have the checksum and the ARQ. So these are some two other methods. Checksum is what? A value is calculated from the data using an algorithm. Value is transmitted with the data. Value is recalculated by the receiver using the same algorithm. If checksum value are different, there is an error. If checksum values are the same, the transmission is success. Okay. ARQ is what? ARQ uses acknowledgement and the timeout. Sender starts the timer when the data is transmitted. Receiver uses an error checking method to check whether the data has been received accurately. If no errors detected, a positive acknowledgement is returned to the sender. If errors detected, negative acknowledgement is returned to the sender. If sender gets no acknowledgement within the set time, it resends the data. So that's the ARQ and the checksum. Okay. Question number 75. The data was sent using an even parity block check. So this time we're talking about the block check. Okay. One of the bits has been transmitted incorrectly. Identify the bit number and the byte number of the incorrect bit. Now let me see if you can answer this question or not. So I'm pausing the video for 10 seconds, maybe 20 seconds. You can have a look and give me the answer. Let's see who can guess the correct answer first. Nope, Steven, your answer is not correct. I think let's not waste the time. Let me give you the answer. So the correct answer is bit number 6 and byte number 4. So these are the bits here. So bit number 6 and byte number 4. This means the error is here, this one. Okay. Question number 76. A small factory uses serial half duplex data transmission to send data from a sensor on the factory floor to a computer in the office. Give one drawback of the company using serial half duplex data transmission for this purpose. So the answer is to transmit, the transmission of the data may be relatively slow. Then second one is data cannot be sent and received at the same time, okay, because we are using the half duplex. And why it's slow? Because we are using the serial. Serial uses the single wire, right? And number 3, maybe more data collision. Okay, and then yeah, that's it. Question number 77. A student uses a mobile phone to take photographs of for a school project. The student needs to transmit the photographs to their computer. They could use the serial data transmission or the parallel data transmission to transmit the photographs. Describe how the photographs would be transmitted using the serial data transmission. Very interesting question. Serial data transmission. So we know in the serial data transmission we use the single wires, right? Single wire to transmit data from one device to other device, and data go in the stream. Okay, so here you can see some reason. Number 1, data is sent one bit at a time. Okay. Second one, A single wire is used to transmit the data from one device to other device. That's the serial, right? 2 marks, 2 points. Question number 78. State one benefit of student using parallel data transmission instead of serial data transmission. So what is meant by the parallel and the serial data transmission? So parallel, the data may be transmitted quicker. Okay, so parallel uses more wires, so that's why data is transmitted quickly. Question, what does the mean, what it mean by the more data collision? So for example, when you're transmitting the data in the single wire, and so data, one bit can collide with the other one. So this is some sort of problem happen when you use the single wire. It also happen with the parallel data as well. Okay. Question number 79. The photographs are also transmitted across a network to cloud storage. A device on a network forwards the packet data towards its correct destination. State the name of the device. I think it's very easy. Most of you know this one. Brian, yes, very smart. It's the router. Very good. Question number 80. 6 statements are given about the method of data transmission. Tick to show if each statement applies to serial, simplex, parallel half duplex, or serial duplex data transmission. Some statement may apply to more than one data transmission method. So statement number 1 is bits are transmitted along a single wire. So which one is, of course, serial, right? So serial simplex and serial duplex. Data is transmitted in both directions. Okay, so it is a parallel half duplex, okay, and the parallel serial duplex, these two. Okay, it's only suitable for distance less than 5 meters. So all the parallel, so serial, parallel simplex, and parallel half duplex. Next one, bits from the same bytes are transmitted one after the other. So it's serial, right? We know this one. Serial simplex and serial duplex. Data may not arrive in the correct sequence. So that is parallel simplex, and parallel half duplex. Last statement is data is transmitted in both directions, but only one direction at a time. So that's the half duplex. So we just is parallel half duplex. That's it. Let's move to question number 81. Umar is a manager in an office. The data that he uses on a daily basis is stored on a file server close to his computer. Data is sent from his computer to the file server using the parallel simplex data transmission. Describe how the data is sent using parallel simplex data transmission. Parallel and simplex. Parallel uses what? Multiple wires. Simplex means can only be sent in one direction. Okay, so data is sent multiple bits at the same at a time on multiple wires or channels in one direction only. Question number 82. A technician is troubleshooting a communication issue between two devices in a factory. The devices need to exchange data, but only one can transmit at a time. Draw and annotate the diagram to show how the data is transmitted between the two devices using the serial half duplex data transmission. Remember, you will always have one question about draw and annotate. So in this type of question, you just don't need to you need to draw and also annotate the diagram. Otherwise, you will not get the full scores. Okay. So here is the diagram. Okay, so computer and the web server, and there you can see we're using the serial data transmission. So this diagram shows the half duplex. A single wire is used to send data one bit at a time. Data can be sent to and from the web server, but not at the same time. So draw and also annotate. So here is the annotation. You can write the details. For example, bits being sent one at a time, bits being sent over a single wire. Data can be sent to and received from devices not at the same time. Okay, question number 83. A technician is setting up a communication link between two servers. The connection will use full duplex data transmission. Define the full duplex data transmission. What is full duplex data transmission? It's a way of transmitting data how in both directions at the same time. So data can be sent in the both directions at the same time. It's a full duplex. Okay. Question number 84. A parity block check can be used instead of a parity byte check. Explain how a parity block check might detect an error in the transmission that would not be detected by the parity byte check. This question is very important. Okay, so parity check can not detect even number of changes. For example, when you send a byte of data and two or the even number of bits are changed, okay, then this method cannot detect the data. So that is why we use the parity block check. Question number 85, a small online business, Crafty Creations need to securely transmit customers the order details and payment information over the internet to their bank. Identify an alternative protocol beside the one commonly used, HTTPS, that could be used for secure transmission of this data. So what is the protocol? So it could be a TLS or transport layer protocol, okay? Transport layer security. The table contains statements about the types of secondary storage. To complete the table by writing the correct type of secondary storage for each statement. Okay, so first one is pits and lands are created on the on a reflective surface. So that's the optical storage. NAND or NOR technology is used. There's the SSD or solid state. Platter are spun that are divided into track and sectors. There's magnetic storage. Electromagnetic are used to read and write the data. That's the magnetic storage. Transistors are used and as a control gate and floating gates. This is SSD, again solid state. Red or the blue laser is used to read and write the data. That is optical storage. Question number 87. Alice wants to send a confidential message to Bob over the internet. She decides to use symmetric encryption. Describe how the data is encrypted using the symmetric encryption in this scenario. Okay, so data is encrypted and decrypted using the same key. Symmetric encryption uses the same key to encrypt and decrypt the data. Data before encryption is known as plain text, and data after the encryption is known as ciphertext. And key is sent to the receiver to allow the data to be decrypted. Question number 88. Rebecca decides to encrypt the data that she transmits whilst using the internet. She does this to keep the data safe. State why encryption helps keep the data safe. Okay, so data will be meaningless if it's stolen. Okay, so you just convert it to the ciphertext, and ciphertext is what is meaningless for the hacker. Question number 89. A computer can have both media access control MAC address and an internet protocol IP address. Give two similarities between a MAC address and an IP address. So what are the similarities? They are both unique addresses, number one. Number two, they both can be used to identify a device on a network. And they are both assigned to hardware, and they can both be represented as hexadecimal. Okay, so IPv6 can be represented using hexadecimal, and MAC address is also in the hexadecimal. Question 90. A network technician is troubleshooting connectivity issue on a local network. Give two differences between the MAC address and IP address that would be relevant to their troubleshooting. So now you need to give the differences between the MAC addresses and IP addresses. First difference is MAC address is assigned by the manufacturer, where an IP address is assigned by a router. A MAC address is represented as hexadecimal, whereas an IP address can sometimes be represented as numeric. A MAC address is normally static, where an IP address can be dynamic. A MAC address has 6 group of digits, where an IP address has 4 or 8 groups. The last point is that a MAC address is 6 byte or 48 bits, whereas an IP address is 4 or 16 bytes, 4 or 16, okay, bytes, 32 or 128 bits. Question number 91. A user has both system software and application software installed on their computer. Describe the difference between the system software and application software. Give an example of each software in your answer. Okay, so number one, system software control the hardware of the computer, allowing the user to interact with it and run application software. Example are operating system, utility program, antivirus program, encryption, compression program, etc. Then we have application software. These software allow the user to perform a specific task. Example include word processor, spreadsheet, web browser, image editing software. So remember, do not write the brand names, okay? Do not write Word, Excel, PowerPoint. Just write the word processors or spreadsheet, web browser, okay? Number 92, give one example of firmware. So there's a Bootstrap program is an example of firmware. The Bootstrap, they are almost same. And BIOS is an example of the firmware. A small business owner, Sarah, is setting up a new computer for her office. Give two examples of system software that the computer will need to function properly. Okay. So number one, operating system, antivirus program, device drivers, encryption software, and the fragmentation software. So you can write those example of the system softwares. Question 94, small business owner need software to manage daily tasks. Give two examples of application software that they might use. So what could be the word processors, spreadsheet, database softwares, web browsers, image or photo editors, video editors, email clients, and games. Next, question number 95. Thomas' computer has operating system. Two functions of the operating system are file management and the memory management. State two other functions of operating system. So here you can see managing memory, managing interrupts, managing user accounts, managing multitasking. Question number 96. A programmer has written a program using assembly language. Identify the translator that is required to convert this program into machine code that the computer can execute. So that's called the assembler. Okay, assembler is used to translate the assembly language program to the machine code. A software development company is considering using assembly language for a performance critical section of their new operating system. Give two drawbacks of using assembly language to write the program for this purpose. Okay, so number one, the programs are not portable. Number two, it's complex to learn. The assembly language is very complex to learn and it's difficult to debug or find the errors. Question number 98, the translators are used to translate the high-level language so that it can be processed by the computer. State what the high-level language is translated into. A very easy question. It's translated into machine code or the low-level language, or you can say the object code. Question number 99. One translator converts and execute the code line by line. Identify which type of translator would do this. That's the interpreter. And question 100. One translator creates an error report displaying all the errors in the code before it can be executed. Identify which type of translator would do this. Answer is compiler.